Good morning, ladies and gentlemen. Thank you to all of you who joined us here in person, and thank you to all of you who are following us through Zoom application. And thanks to everyone who are following us on YouTube and Face channel. My name is Martin Buchan. I'm welcoming you on behalf of the County of Split and Dalmatia SUSHI Drop project. This is the second day of our conference, InnovaMare SUSHI Drop, which deals in a specific way the possibility for the improvement of technological innovations, for improvement of technology of management of our sea. So before we start today with the introduction to today's agenda, I propose you to see an inspirational video of our famous photographer and the person who is working in the Ministry of Agriculture, the Fishing Department, Mrs. Ivana Viletic, so that you can enjoy the beautiful scenes of Mediterranean and the photographs that she prepared. Thank you.
Stavi ruke, Gospojo, nad zabranjene pučine, nad ova polja nestalih. Pogledaj na mene, nek se jednom raskaju svi ovi košmari. Vječna pjesma si ljeta, kao roditeljski glas, moja se sakrila, pukla na pola. Na meni nek sve je tvoje, Gospojo, i ja sam narod tvoj. Stavi dlan na čelo moje, Gospojo, ne daj da propadnem. Stavi ruke, milosna, noć je digla šatore, magle sjele na vrhove. Pogledaj na mene, na tijelo krivnje pale su, ko crven mjesec na obale. Vječna pjesma si ljeta, kao roditeljski glas, moja se sakrila, pukla na pola. Na meni nek sve je tvoje, Gospojo, i ja sam narod tvoj. Stavi dlan na čelo moje, Gospojo, ne daj da propadnem, ne daj da propadnem. Stavi ruke, Gospojo, nad zabranjene pučine, nad ova polja nestalih. Pogledaj na mene, nek se jednom raskaju svi ovi košmari. Vječna pjesma si ljeta, kao roditeljski glas. Moja se sakrila, pukla na pola. Na meni nek sve je tvoje, Gospojo, i ja sam narod tvoj. Stavi dlan na čelo moje, Gospojo, ne daj da propadnem. Stavi ruke, milosna, noć je digla šatore, magle sjele na vrhove. Pogledaj na mene, na tijelo krivnje pale su, ko crven mjesec na obale. Vječna pjesma si ljeta, kao roditeljski glas. Moja se sakrila, pukla na pola. Na meni nek sve je tvoje, Gospojo, i ja sam narod tvoj. Stavi dlan na čelo moje, Gospojo, ne daj da propadnem, ne daj da propadnem.
Thanks, Ivana. I hope you enjoyed the beautiful photographs and the music that she prepared for this part. So, related to the agenda and to the participants that are going to join us as lecturers, I kindly asked them to exclude this part regarding the simultaneous interpretation on the right part on their Zoom. For the rest of you who are following us on Zoom or on social, please, if you have any questions, you have that part in chat, and you can put your question, and at the end of all the presentations, we can, if there is any need for that, for the answers or additional explanations, we will answer to you. If not today, we will register your question and submit the reply for a coming period. In the next set of lecturers, I'd like to announce Mr. Luca De Marti from Alma Mater Studiorum, University of Bologna, Introduction to the Sushi Drop Project, followed by Mr. Massimiliano Menghini from University of Bologna, Mr. Giorgio Ricobene and then Mr. Ivan Blažeković from Primotronic company, and in the last part of the first part of today's session, Mr. Joško Pedišić, a fisherman, he will tell us the perspective, how the fishermen are looking at these problems, at these issues. Mr. Luca De Marchi, if you are ready, please join us.
Good morning, everyone. Can you hear me?
Yes, we can hear you.
So let me, hello, Martin. Let me share my screen. Okay, can you see it?
Not yet. Now, yes.
Thank you very much. Let me take this opportunity to thank the organizer, Martin, Katarina, and all the others. I'm very happy to share the results of the SUSHI Drop project. As you will see, I think that we have developed a very fruitful cooperation between Croatian and Italian partners. Our aim was to create a research platform with two main goals. The first one is to introduce novel, sophisticated technology related to robotics in the blue economy field, and certainly the first and most important goal was to help the protection of the biodiversity, thanks to more data, more knowledge shared openly. So I will just briefly recap the history of this project. Then I will leave the floor to Massimiliano Menghini, who will give you some more technological details. So first of all, of course, we have to acknowledge the Interreg Italy-Croatia program. We applied to the 2017 call. Among the targeted action in that call, there was the increase of the marine and environment knowledge through the establishment of biodiversity mapping. So we decided to address this call by creating a novel drone, so an unmanned vehicle suitable to characterize the biodiversity, also to perform a more sustainable fishery. So more into the details, the specific objective 3.2 was precisely the contribution to protect and restore the biodiversity, and among the actions to be supported, there was this one, that is the increase of the knowledge. Basically, we are living in a world data rich, but actually the sea environment is data deficient, in the sense that it's very difficult to gather information, to collect information, especially related to the seabed health status. So we are targeting this problem, and the SUSHI Drop project has a duration of about 3 years. It was extended due to the COVID emergency. The total budget was around 1.7 million euros, and the main outputs are the drone itself, that is this unmanned underwater vehicle, so an autonomous vehicle. The output of the vehicle itself is data, basically. So we are aiming to create a database, georeferenced with the images and sonar scanning acquired with the drone. And on the basis of this knowledge, we want to find new strategies for biodiversity conservation. To achieve these outputs, we have created a consortium which includes scientific institutions such as the University of Bologna and the Oceanographic Institute of Split, local authorities, the Split Dalmatia County, Regione Marche in Italy, and also some fishermen and an environmental association, Flag Costa dei Trabocchi and Sunze in particular. So why UUVs? Well, first of all, because this technology is now getting more and more ready for practical usages in different application fields, not just for scientific purposes, but also in military field, for example, and also for the oil and gas industry, for example, to detect oil spills. So it's there is a huge variety of application for this technology. Then we have to say that this drone technology, even if it's very novel, still allows to reduce cost if compared with alternative means to assess the biodiversity. And practically, UUVs are the only mean to reach a certain result, like the assessment of the health status of areas at deeper depth than 200 meters, for example, where these areas are unreachable by divers. So the territorial challenge of our Adriatic Sea is also very interesting, because, as you all know, the Adriatic is an hotspot of biodiversity for several species, and so and in some cases the bottom is rocky, so it's practically impossible to assess the health status with traditional fish sampling. So UUV basically can be the only mean to assess the quality, the environmental status in this context. So the workflow was related to the assessment and the development of the drone. Then we have we have installed all the sensors which are needed to collect the data. And currently, we are on the verge of realizing the first surveys. The last step will be related to the database creation. It will be an open database, publicly available. I don't want to enter the detail of this part. I will leave this to Massimiliano. I want just to quickly conclude my presentation with some concluding remarks. I think that as you will see with the presentation of Massimiliano, I think that we have proved that this Interreg framework is also a viable solution to develop very sophisticated technological advances. And I want to stress also the fact that the actions of this project are pretty much in line with the newly developed user action plan. So, for example, we are compliant with the goal of developing research, development, and innovation platform, in particular related to marine robotics. We are also in line with the scientific cooperation on fisheries and fish stocks, because basically, again, the optimization, the realization of sustainable fisheries is just feasible when you have sufficient data to optimize this process, and all the actions related to data and knowledge sharing and increase marine knowledge. Thank you again for this invitation, this organization. These are our contacts. Again, I would like now to leave the floor to Massimiliano for his technical content.
Okay. Could you hear me?
Yes, we can.
Okay. I'll try to share my screen. Okay, here we are. Could you see the slide? Okay, so good morning, everyone. Thank you very much for the introduction, Luca. I am Massimiliano Menghini, Research Fellow for the SUSHI drone project, and today I will show you more closely our drone, Lucy. As you can see in the slide, the drone is constituted by a large variety of subsystems and payload. The design philosophy followed by the project was to develop a multi-purpose and modular unmanned underwater vehicle in order to customize the drone to the different mission scenarios. Moreover, the payload can be modified according to the different tasks to be performed. Mainly, the drone subsystems are divided into two kinds of subsystems. So we have subsystems for guidance, navigation, and control, and science payload. During this presentation, I will show you the data that we are going to gather during the mission campaign that will start from May. And here is Lucy. As you can see, in order to decrease the hydrodynamic resistance and protect all the subsystem, all the external surfaces are covered with panels. And moving on, the types of navigation, we have mainly the drone can be piloted mainly with two navigation modes. The first one is the Rov Navigation Mode, and this means that the drone is used as a remotely operated vehicle, which means that it is directly connected to the ship or mission station through a fiber optic cable, in which all command and information flow. This type of navigation is required for close range inspection, where maximum precision is required, as for example, fish nets inspection, close seabed inspection, or when the drone is in narrow space. The second navigation mode is the autonomous one. This means that the drone is used as an AUV, so as an autonomous underwater vehicle, and it will communicate with the mission station through the ultra-short baseline system, that is an underwater acoustic communication system. And of course, this kind of navigation mode requires a careful planning of the path to be followed by the drone. And mainly it is required during multi-beam and bottom camera data acquisition. As I said before, I will show you all the types of payload that are on board of Lucy. Let's start with the multi-beam echosounder. Onboard Lucy has an R2 Sonic 2020 multi-beam echosounder, which allows to acquire bathymetric data and information on the water column. The bathymetric data give information about the morphology of the seabed, highlighting the presence of object or fish nest. The water column, instead, will give information regarding the presence of gas bubbles or the presence of fish banks. On board, we have also two types of camera, the pilot camera and the bottom camera. The first one is used for piloting the drone in Rov navigation and to acquire photos and videos of the surrounding environment. Instead, the bottom camera acquires high-resolution photos for the 3D reconstruction of the seabed. This kind of 3D reconstruction will be merged with the bathymetric reconstruction, obtaining a more accurate characterization of the seabed. Moreover, on board on Lucy, there are sensors for the characterization of the physical quantities of the marine environment. These are the mini CT and mini CWS, which measure temperature, pressure, conductivity of the water, and the velocity of sound. And this data will allow to model the underwater environment of the entire water column. And last Thursday in Genoa, we have performed the first sea test of the drone, where we have checked the proper functioning of the guidance, navigation, and control subsystem. And in particular, we carried out the buoyancy calibration test. And we also did some performance tests to identify the parameters of the mathematical model in order to calibrate the autopilots. In the coming days, we will return to Genoa to continue these tests. And also we will do tests on the payload to prepare the drone for the first official mission in Split. And I will show you 2 videos of the mission. This is the first time lapse in which it shows the maneuvers to calibrate the yaw autopilot. And as you can see, in order to set the autopilot parameter, it was necessary to perform maneuvers rotating constantly the drone. And once configured the yaw autopilot, we continued with performance characterization test. And in this video, you can see an example of forward navigation with the yaw autopilot activated. And if I remember well, in this case, the forward speed was set at 1 meter per second. And in particular, we are simulating the acquisition with the multi-beam. And of course, for safety reason, the drone has been piloted in visual line of sight. As anticipated during this month, we focus on the preparation of the drone for the mission by carrying out performance tests and pilot training in the port of Genoa. In the second week of May, we will go to Split to make the first survey for the project. And the area of interest for the mission is situated in a channel between the island of Solta and Brenik. We will continue to perform tests for the tuning of the autopilot parameter, and we expect to acquire scientific data using the 2 cameras and the mini-CT and mini-CWS. Instead, in June and July, we will focus on the PEDASO mission along the coast of the Marco region, where we will carry out surveys, acquiring data with the multi-beam echosounder. And after the PEDASO missions, we will move to Fano until the end of the project, where we will perform some tests in the sea and in the lakes, where we hope to perform tests in autonomous navigation mode. Of course, we will continue to sample data with all scientific payload on board of Lucy. And as said before by Luca, the huge amount of data collected in each mission will be processed and geolocated, creating an open access database to find new strategies for biodiversity conservation. And I think that that's all, and thanks for your attention.
Hello, I think that we got a message in the chat asking about the minimum depth for operating the drone. The minimum depth is around 200 meters. I mean, we can go a little bit deeper, but let's say the sizing and the specification were conceived for this maximum depth.
Okay. Does we have any other question? Da li ima neki drugi pitanja možda iz publike?
Any other questions from the public? Naimanya?
Oh,
Did you hear the question?
yeah,
They asked
yeah,
about the
yeah,
minimum.
yeah. The drone can float, as you have seen. So basically, it can navigate on the surface, of course. So the minimum depth is the height of the drone itself is around 60 centimeters, and the multi-beam sonar is multi-frequency. So let's say the blind region below the drone is relatively small. So if the question is about the water column imaging, we can start with to image the water column at very small depth. Could be, I would say, less than 2 meters. Of course, the imaging is just below the drone, so it's 60 centimeters in total.
Evo, nadam se da ste zadovoljni odgovorom.
Hope you are satisfied with the answer. If you have any questions, please contact directly. Our technicians will submit the question directly, or you can send your question in chat so that everyone can see your question. Mr. Giorgio Ricobene is ready to join us.
Yes, good morning, everybody, and thanks for inviting me to this very nice workshop and conference. I will try to share my screen. Just tell me whether you can now see my transparencies. Can you see them? Okay, so very good. So I will provide probably a talk which is a bit out of topic with respect to your Interreg, but I hope it's interesting for you as well. So okay, I will move out this window. I'm sorry. Okay, very good. Done. Okay, so I will deal with cable deep sea acoustic observatories and their scientific and technological application. Okay. I have to find, sorry, the right way to move my transparencies here. Okay. So the main point for using acoustics to explore deep sea is the fact that the sound has a very low absorption length, and thus it's an excellent probe to study a variety of phenomena in water. Ranging from geophysics phenomena, earthquakes, volcano activity, etc., ocean and atmosphere physics using waves, sounds produced by rain, waves, but also making a real tomography of water thanks to absorption length, disentangling the effect of different absorption length in water due to acidification, for instance, or temperature. To study the noise pollution, which is a requirement of the European Marine Strategy, in particular Indicator 11, to study bioacoustics directly with a lot of emitting bioacoustic sources in the sea, and high energy astrophysics. I will give you just a short snapshot on this because that's why I'm here. I'm an astrophysicist indeed. And of course, there is a plethora of industrial applications ranging from deep sea exploration, communication, and use of very precise positioning systems. And this, in the figure on the left-hand side, you can see really the variety of sources that you can find underwater and produce sounds. So in the lower part of the, I hope you can see my mouse. So in the lower part of the plot, you can see which is the origin of noise, which ranges from seismic and then moving on shipping and then bubble and spray and then thermal agitation. But on top of that, you can find several natural, biological and human phenomena, anthropogenic phenomena. So you can what you really want is to measure the spectrum ranging from a few millihertz to hundred of kilohertz roughly, to get really the full soundscape of the sea. And as I said before, especially at low frequency, sound is extremely interesting because the absorption length is very, very long, ranging for kilometers, and hundreds of kilometers are very low frequency. That's why, for instance, baleen whales use sounds to communicate over oceans. What is the situation with cabled observatories? These are really the new frontier because they permit to have unlimited power for your stations and almost unlimited bandwidth using optical fibers. So you can really perform long-term real-time observation using these new features. Of course, we have a con, which is to have a fixed site, and it is a cost-effective application. But if you look overall, it is not very much cost-effective because you have an enormous possibility to gather data there. So the situation is at present, I mentioned the most important, infrastructures. In North America, we have Canada and North America, the western coast of Canada, North America and North US, which have a cabled observatory, a very large network there. We have Jamstack in Japan. We have a planned Hawaii observatory, and in Europe we are not so bad. We have observatories in the northern waters, in Spain, for instance, and these are grouped under the Jericho Research Infrastructure. But also we have the EMSO ERIC, which has 2 sites in Ligurian and Western Ionian Seas, and the CAM3net ESFRI infrastructure, which is very much linked to EMSO in these 2 sites. So I will discuss in particular about the Western Ionian application, and the place where I live, which is Catania, with the Istituto Nazionale di Fisica Nucleare, Laboratori Nazionali del Sud, has installed 3 cables underwater, 1 offshore the coast of Catania, this is Sicily and this is Calabria, and 1 offshore the coast of Capo Passero, which is this extreme southern tip of Sicily. And they arrive at 2,100 meter depth and 3,500 meter depth with different type of cables and infrastructure. This is a limited infrastructure, but very useful for geophysical and multidisciplinary studies, as I will show. And this is the site for the development of a new application, which is a Neutrino underwater telescope under the CAM3net consortium. They are really what I love to call them gateways to deep sea, because we are really acquiring continuously data from deep sea with several infrastructure. And on the left-hand side, you can see the shore lapse. Let me carry on. So the idea is to have really a continuous optical fibers from deep sea to the main site, which is our lab in Catania, that is also connected through the Jean consortium and GAR in Italy to the entire network. So you can really access from your mobile phone data from these observatories which are deployed underwater. We have this NEMO SN1 station, which is under the EMSO consortium, and these 2 acoustic observatories that I was the PI for both of that, which were deployed in the first round into 2015 and in 2005, and this is still running since 2017. On top of that, I will shortly discuss about the focus application, which is the use of in the entire optical cable as a fiber. As a distributed acoustic system. I will not go through details, you can ask later on, but the first experiment was this one, ONDE, which stands for Ocean Noise Detection Experiment, which was really aimed at measuring the noise spectrum in view of using this information as a background for possibility detection of neutrinos underwater through the acoustic technique. But this turned out to be really a very sensitive monitoring system for whales. So nature gave us the opportunity to have a paper on that in 2009, and I hope you can see them. These are the sounds that we heard from sperm whales immediately after the deployment of the station. We measured sperm whales sounds for 2 years, and thanks to the capability of having an acoustic synchronized antenna, we could also detect the features of the pulse interval of these clicks, which is a proxy of the size. So we had a census of the animals, and also thanks to the tetrahedral distribution of the hydrophones and their synchronization, we can really track the dives of the sperm whales down there. We continued, of course, with the analysis, and actually provided a distribution as a function of time and as a function of route of these animals. And you can see here in the plot on the right-hand side, which is the area that we cover, which is close to 900 kilometers square, which is quite huge with a very small station. As you can see, here is another example. We studied the clicks and whistles of dolphins, and in particular, analyzing the clicks, we could evaluate over 2 years that the clicks are emitted at night. So this is a proxy of the preying activity and breeding activity of the dolphins, with a clear identification of the real activity. From 2017, we improved the station with a GPS connection, so we have data tagged in GPS time properly, and we extended a bit the range of frequency from 96 kHz sampling to 192, and we're running this detector now with optimal results, and you can see, I will show you. Okay, that's it. Some examples. This is a daily spectrogram that we get. We compute spectrograms every 5 minutes together with the real-time data gathering, and you can see the sperm whale clicks, dolphin clicks, but on Ollie we can measure the ship noise and the earthquakes. And this is, for instance, a signal of the Etna strombolian activity, and we have a full soundscape of the Etna eruption, for instance. You know, there was a major eruption starting from December to date. Another interesting point is that we concentrated on 2012 and 2013 on low-frequency hydrophones. So we installed low-frequency hydrophones on EMSO SN1 station, and this was mainly used for geophysics. It was a kind of OBS, but together with that, I hope you can hear it, we discovered the Balanoptera physalus, and we could track it along the very long period of 1 year, clearly identifying the signals. And another important application was that we could really analyze the air guns emitted in two operations, one scientific, one of industrial interest, off Greece. What you heard are air guns signals, which are 10 dBs more than the typical sound spectrum. So, and they are hundreds of kilometers far from there. Another interesting hint is that we could hear air guns, but in that period we didn't find the fin whale. It's not clear yet if it is just masking or the fin whale really prefer to move out for some reason from the area. Other important point is the measurement of indicators 11.2 from marine strategy, and here you can see a spectrum which holds all the 2 years data from ONDE, and this is the spectrum as a function of frequency. And in particular, we analyzed the 63 and 125 hertz and correlated with the AAS data from the ships. And you can see a very nice correlation between the ship's passage and the noise produced. We then produce noise map. We can produce noise maps in the area, and this is the passage of ships. You can see here in red, which is very, very much in agreement with the noise recorded. And of course, you can also really detect the acoustic signature of a single ship. So you can really pinpoint if a ship is out of standards in terms of acoustic noise, or is producing, or it's very dangerous for the environment there. So it's an extremely powerful method. Another very interesting application that we are exploiting since less than 1 year is the use of optical fibers as acoustic distributed sensor. So we installed a Rayleigh and a Brouillon detector, backscattering detector, and we use the optical fibers that we have here as distributed sensor. You see here a very nice event recorded at our cable, which is a very nice coincidence with the ones measured on the Etna, with the network of fibers that we have there. This is a project in collaboration with GFC Potsdam and several French institutions which have an ERC project called Focus, led by Marc-André Gutcher. I'm running out of time. The last application I would like to talk about is the fact that we have in Capo Passero here, as I shown before, but also in the Ligurian Sea, the SCAM3net Neutrino Telescope, which is an enormous architecture made of more than 300 strings deployed underwater. The strings are deployed like this in compact, but then once they are deployed and connected to the main infrastructure, they develop for 700 meters. And they are equipped with mainly optical modules to detect neutrinos. If you're curious, I can discuss it later on. But they're also equipped with acoustic sensors that permit environmental monitoring. And for the sake of the project, we developed a new acoustic positioning system. We use the very precise time calibration system of the detector that we developed based on a wide rapid application of which is an extension of PTP. And thanks to this, we have a really synchronized array. So we can, I skip the details, but you can see here the movement of the strings, which are very well tagged with a precision of about 50 centimeters constantly. And this is these are some of our sensors and emitters. Really a short glance of what we want to do as well, which is to detect the interaction of a neutrino in water that interacts indeed with water molecules. And if the energy is very high, we can have an acoustic signature that we want to detect with our detectors. This is work in progress, so I will just show this. And I come to my conclusion. I'm sorry, I'm something like 1 minute off, but okay. The cabled observatories can really provide unprecedented possibility for marine science and technology. The acoustic data are relevant for the MSFD implementation, but also for marine splash planning. I think this is a very new frontier that we have to investigate. We have, and what I would suggest really is that instead of having just few observatories in the Mediterranean, people start to think to a network of observatories there. That would be really a perfect tool for that. We have a reliable low-cost technology for designing synchronized array of hydrophones, and which is used now extensively in these two infrastructures. We have test benches available in East Sicily, two, one in Catania and one in Capo Passero and one offshore Toulon. We have real-time data that people can really access, and digital libraries available. And last but not least, we will use optical fibers as distributed acoustic sensors. So that's all. I hope I'm not too late for the presentation. I hope this is all was clear.
All of us, thank you a lot in your presentation. So, may I call Mr. Alan Ivan Blažeković from company Primatronic that came.
Okay, I'll stop sharing.
If you will have some question, it will be answered. Oh, sorry, we have one question from the public. Sorry. Can you hear him? Just a minute, we will give them a microphone.
Yes.
Thank you for the presentation, very interesting. Just a quick question on the tracking one single ship noise. If you have two ships having similar routes, how easy is for you to individuate each ship acoustic signature?
Okay, this can be done in two ways, okay? If you just rely on the acoustic signature, the main acoustic signature that comes from the keel and machinery, it's very hard. But with two ships, if you detect the propeller noise, which is really high frequency, with our station, this is possible because we have a limited size at the moment to make a proper triangulation. Another possibility, and we're exploring this, is that the fact that the Catania cable, for instance, as I didn't went into details, but probably you have seen this, as a Y shape. So we plan to use this characteristic installing one station in the south branch, which is the small onda that you have seen, and another station, which is SN1 in the north branch. In this case, the lever arm is sufficient to disentangle the two ships, also using the machinery noise and not only the propeller high frequency noise. Was that clear?
Yes, it is clear. Thank you a lot on your answers. So, did you have, da li imamo još nekih kakvih pitanja u pitanja i odgovore u Zoomu?
Don't there any other questions?
No, it's not for you. Ok, nema nikakvih pitanja. Evo, najavljam gospodina Ivana Blažekovića.
There are no other questions, so Mr. Ivan Blažeković, your presentation, the floor is yours.
Hello, everyone. It won't actually be a presentation, it will be a movie, and I'll be talking over it. We are living on a really nice planet. It's abundant with life, but we have a situation. We people, we like to have an abundant lifestyle as well, which leads to a collision between the two systems, the ecosystem of our planet and our lifestyle, the material way of living. So what we are seeing more and more pollution created by us, being it plastics, being it poisons spilled into the sea, being it fertilizers, being it oil spills, plastics, degradations, microplastics. These are causing severe damages to the ecosystem. And we have to look into it, what is happening, how are the CO2 emissions going on, what's with the climate change, how is water temperature affecting life on Earth, what is with overfishing, what is with the destructions of the systems. We want to live in a world which is like it was, let's say, 200-300 years ago. So let's see what we can do to monitor, see, change, and keep it the way that it was. In the past, we started, let's keep it on, so with this beautiful big picture of plastics. So what we did in the past, we were doing spot samplings. Why we did that? It was like, you didn't have the equipment, the technology, the possibilities. So you would go out there, take a bottle with you, take a sample of water, and go with this sample of water back into your lab. This system is a little bit limited because you can only do it when the weather is nice. You have to refrigerate your sample, get it back into your office or into a lab, and then in your lab you have already maybe contaminated your samples. Luckily, technology is going on, so today you are actually taking your labs with you. So while the sensors which were previously only available in your laboratories, nowadays you can take almost your whole laboratory with you. And in the future, we will probably be capable of taking the whole laboratories with all possible sensors which you only can imagine to measure whatever parameters you are thinking that are needed, could be done in situ on place. But you would still be limited the fact that you do it only once a month, if you're lucky. Usually you do it only a few times a year at only one spot. So we are looking into long-term monitoring. And the easiest way is you take what we are doing as a spot sampling, you put it on a spot, but this time you do not need anybody to go out there by themselves, take one sample, but you just leave the monitoring platform out there to do this job for you. So you put solar panels on it, you put batteries, so you have the power supply, and then it's only sky is the limit of what of sensors you are going to put up there. You can have the sensors in the water, on the surface only. You can have the sensors down below. The sensors can communicate with you all the time. So you are getting data every 15 minutes, unlike before you had one data point every month or even worse. But this is stationary again. You are in a spot. So with the advances in technology over the last years, we are now moving, as we heard on this conference for many times, to autonomous vehicles or remotely operated vehicles. It started with remotely operated vehicles, but with the technology getting better and easier to use, we are nowadays capable of putting sensors, cameras, sample grabbers onto unmanned vehicles, so we can get our data from places where we couldn't even imagine it before. And you don't have to send people in there, so you're not risking divers, but you have a machine that goes where you programmed it, and it takes the data, pops out of the water, or if it has, as we heard, acoustic sensor, acoustic communications, it will give you the data directly while you're doing it. And here again, sizes vary. The bigger, the more you can do, but the more expensive it is. But what I see with this is limiting a bit. And we heard already yesterday that money can be an issue. So luckily, the pleasure part of the business is introducing new drones, which are simple, easy to use, and which are opening a complete new area. Unlike those huge, big things for which you need big ships, now you have a simple device which just flies or swims next to you, dives next to you, takes pictures for you, has data sampling available. Moving from there out of the water, we do not even always need to take new technologies. Sometimes you already have the technologies. You have X-band radars on ships. Usually you use them to detect another ship or to see the coastline where it is in pure visibility. But through software and firmware upgrades, you suddenly can use existing radars for totally different things like detection of wave patterns, heights, surface currents, things like this, oil spills. Combining this with infrared cameras, you are looking into a whole new range of possibilities with already existing equipment, which you have already installed. Another thing which is going on is that space technology is getting cheaper. Space launch systems are getting down in price as we speak. So while before it was $1 billion project to send up a weather satellite, nowadays we are talking millions. And the satellites are getting smaller, so it will be easier to get more of them up there in the air and start looking at our planet. And while maybe in the past we were only able to see temperature, nowadays with advances in technology and precision of the instruments, we can measure the state of sea levels. We can look at biomasses, at plastic masses which are accumulating. I wouldn't wonder that one day we will be able to count the fish in the water out there from the sky. The possibilities are endless, and the more satellites are going out there, the more there will be. Another thing is we have more and more fixed installations out there in the sea, on which, again, a lot of data available is collected. So to return back, in the beginning we had one sample per spot in a month. In the meantime, we can have an abundance of data from all possible or never thought of places, like ships, like wind turbines, like oil platforms. And this is all very simple to collect nowadays. A thing of the future is Internet of Things. And with the Internet of Things, or IoT, we are getting to this, that collaborating will be far easier. Technology will be easier and more available to everyone. And this is one thing which I see in the future maybe as something which was maybe not used enough in the past. And that's all of us, we the people, I would say this, citizen science. Okay, I know the situation is a citizen has his equipment which is not properly calibrated, it's not to a scientific standard, but again, with having many people being there out there doing science, and you would wonder, it's not like that people take this lightly. Some invest some serious money into their equipment and would like to cooperate and share their scientific results and findings. But you can do it even simpler. I was just thinking, probably on every pleasure craft nowadays, you have at least a thermometer, if not a fish finder already. Most of these crafts nowadays are equipped with internet connections, so data could be streamed from them into a cloud or computers, whatever, databases, and collected from many, many sources. Just imagine in the Adriatic Sea, on the Croatian side, if I'm correct, there's over 20,000 charter yachts waiting every summer to be taken out to sea. Just imagine 20,000 data points which are reporting in every 15 minutes, 10 minutes, 30 minutes. Which brings us to big data. All of this data is, of course, not really coordinated. It had to be normalized, but nowadays technology is going into that direction that artificial intelligence can help us a lot normalizing this data, discarding data which is useless, and looking into valuable data and help us modeling, because it's far better the more data you have to get a good predictive model of what is going to happen than having only one spot sample from the beginning once per month. Although one might say, as a joke, okay, if you have only one data point, it's far easier to create a model than when you have tens of thousands of data points. So the inclusion of citizens could be a game changer in acquiring huge amounts of data. But one should not forget that we have fishermen out there all time of year almost. With them, their boats, for them, they already have sensors. They have fish finders, they have temperature sensors. I have been discussing with some current meters, which would be interesting for them. So these boats could as well be included in the data collection suite for the future and giving us even more data. They could have on their nets cameras installed to give us a vision of what is going on down there in life at the moment as the fishing net is dragged behind them. So looking into the future, I might say that technology is getting cheaper, it's getting more available, it's getting simpler to use, it's getting more connected, it's getting autonomous. There is artificial intelligence which will help us deal with all of this data. And with all this interconnection and collaboration between us, the people, the scientists, the scientific community, the businesses, the fisheries, the governments, we can all contribute that we get back to the state how our seas were before we started having a great time here with our plastics and material life. Thank you.
Thank you, Ale. Da li imamo kakvih pitanja, eventualno?
Do we have any questions?
Nema nikakvih pitanja. Na protekloj prezentaciji je bilo
No questions. In the earlier one, there was a question connected to
interesantnu i detaljnu prezentaciju.
Interesting and detailed presentation.
I da li imaju primjer erupcije
do they have any examples of the eruption of Etna?
Da li nam može reći o
Or
planima za 2022
can something be said for the plans of 2021 for Capo Passero Observatory?
Gospodin Gigi Ricobene,
Mr. Gigi Ricobene, if not, we will answer these questions later.
There's a question to me, sorry.
Yeah, it is the question in the
chat.
And the answers in the chat for the.
Yeah, I answered directly to Azra.
Okay, thank you a lot. Thank you a lot.
This was answered directly. If you want, I can copy paste for all the audience.
It will be nice. Thank you.
Okay, I will do that.
Evo, da li ima kakvih pitanja još kate možda u međuvremenu za gospodina Blažekovića? Evo, ja mu najljepše zahvaljujem na prezentaciji.
I thank Mr. Blažeković for his presentation, and if there are no further questions,
tehnologija može
I thank him for the possibilities. Now I would ask Mr. Joško Pedišić to come to the floor. Thank you.
Dobar dan svima. Pozdravljam sve prisutne.
Good morning to everyone. I'd like to greet you all. I will just give you a standpoint of a fisherman and say how can we contribute to the improvement of the work of fishing boats, namely to diversification. Talking about ecological and tourist trawling, I've been doing for many years. I will introduce you with this. Generally about the project has been done in collaboration with the UNDP within Coast Project, in which 4 counties were included. The project itself was done under the leadership of Lag Laura from Biograd on the Sea. When the project was finished, the vessel Jadran 3 had the certificate confirming the value of the project of biodiversity, sustainable green development of the Dalmatian coast. Now, what does it mean? Why ecological? While trawling and ecology so far did not go together so often, so that's why we would like to go into details and say something more about the aims of the project. So the aim of the project was, in order to receive this certificate, the reduction of the fishing effort or diversification. We said we are going to clean the seabed of Adriatic. As you know, the trawling, the net is going at the very seabed, some 30 meters wide. So during one fishing operation passes some 4.5 nautical mile. Everything that is at the sea bottom, not only fish, but some objects, plastics, everything is caught in a net, and we bring it, take it to the coast. Now, demonstration of trawling fishing. I'd like to say that this is not fishing, this is not trawling, this is a demonstration of how we fishermen, how we are doing our job. So just to explain to our guests, our tourists, how we do our professional job. And finally, enrichment of the tourist offer. This is a special form of tourism that we would like to supplement with many other things, because it's only we that are licensed, only authorized fishermen can perform such an activity. Now, about the dynamic of the trip itself. What is the plan? So the plan is fishing is always, as you know, in morning or in the evening hours, but we have to adapt our trip to the tourists, to our guests, so it should be performed at the time which is not so favorable for fishing, which is the mid of the day. So we are leaving the port at 9 a.m. like all classical tourist trips when they are going to visit national parks or similar. So the fishing starts at 10 a.m. because the very operation, I adapted it to the place Primošten, which is only 45 minutes far from the area where fishing is allowed. So it is the closest to the fishing area. So the fishing itself starts at 10 a.m. The fishing operation starts for an hour, hour and a half. So at noon we already have fish on board. So to our guests on board we say that they will eat what they will catch. So they are skeptical. What if we do not fish anything? What shall we eat? We paid and there is no food. But in this 9-10 years that I've been doing this, it never happened that there was no fish at all, because trawling means no big quantity, but enough for feeding our guests. So at 1:30 p.m. We entered the anchoring site, and then we start with the preparation of fish and everything else. So at 2:30 the fish is prepared for degustation. So it's not like a fish picnic or anything like that, but literally fish that was caught an hour ago. Meanwhile, guests are swimming in the sea, and we are preparing the fish, and they have this feeling of seeing how to eat freshly caught fish and not some fish caught 2 or 3 days ago. At 3:30 we leave the anchoring site and we come back to the port at 5 p.m. This is just shortly. There are many things going on in between, but I don't have enough time to show you everything. everything that is going on. But the outcome of the arrival to the port is well known to me, because the guests that are joining me at this fishing, they don't want to leave the ship when they come back to the port. For example, if there is close to me some boat that was on a fish picnic or a similar trip, they are leaving the boat immediately. But guests on my boat, they do not want to leave the boat. So, and we have some 40 or 50, maximum 40 or 50 people on board, so that people can have this maximum feeling, that they can feel this joy of taking part into fishing and spending a day at open sea. So what is going on at such a fishing? I have made a comparison with the classical trolling and trolling for tourist purposes. When this is done for tourist purposes, then we have the fishing 1.5 hours, while in summer the trolling itself is 15 hours. So we have this ratio 1 per 10. 10 times the fishing effort is reduced compared to classical trolling. Also, similar is with the consumption of fuel. The boat daily spends 500 liters of fuel in summer, while with the trolling, with tourist trolling, it spends 140. So I need 1/4 of oil. Now we come to the most important part, and that is the effect of, sorry, I skipped one slide. Financial effect of this tourist trolling. It's important to stress that we do not catch fish. We catch money. Here with fishing, as you can see, we get much better financial effect. As you can see, gross income daily is 1,600 euros, while average fishing for this boat that I'm working on would be 1,000 euro daily during summer. So it's more than 50%. This financial effect is better in tourist trolling, because this income is achieved through selling of tickets, 60 euro per ticket, then some 30 passengers with some children. More or less, this is the figure that we achieve. The income is also much greater from tourist trolling related to the classical trolling, because with classical trolling the inputs from fuel are much higher, because this is a great cost when we talk about classical trolling. So income is much higher with the tourist trolling. Just a short chronology, as I've been doing this for more than 9 years, I made this chart with which I want to show, to present how it started since 1220. Here you can see the bigger ratio of classical trolling related to tourist trolling, but you have to take into consideration that the tourist trolling is done only in summer months and only 2 or 3 days a week. All the rest, a boat has other functions, so it can be used also for classical fishing. So one day it can be used for tourist trolling, and next day it can be used for classical fishing and trolling. So here you can see the constant increase of income from tourist trolling. Apart from 2020, no income at all. So I just put it here, but no indicator for 2020. So 35% is the income higher from tourist trolling related to the classical trolling, looking for the whole year period. But and this tourist trolling is done only in 1/3 of the year. So hopefully in some future, I hope these two columns, red and blue, would be equal. I'd like to conclude that which are the advantages and which are the disadvantages of tourist trolling. First advantage is the financial effect, much greater income for me, as the owner of the fishing boat, from tourist trawling related to classical fishing. And I keep on repeating to my colleagues, I keep on telling them that it's worthwhile for them to pass to this tourist trawling. Then the reduction of the fishing effort, and with tourist trawling, less potential effect on environment, because my aim is not fishing but just to do the demonstration of the fishing, where we catch only the quantities for 30 or 40 people to eat to have lunch, which is 10 times less than with classical trawling. Then extension of tourist season, which is also very important, because tourist trawling can be done also in months which are not so good for swimming, because it does not depend on the swimming, but it depends on weather conditions outside only. Then education of our tourists, we would like to show to our tourists the real way of life of professional fishermen, what is their job, and we want to raise this awareness of me and my colleagues, so that they can see that we are not just catching, just fishing, but that we are also collecting waste and plastic from sea. We bring it to the coast, we give it to the communal society, to the recycling point, so that our guests can have a different impression about us fishermen than they had it before. And what is also important is this relief, so to say, of fishermen. Before that, my fishermen used to lose the good temper and the wish to do this job, classical fishing. But working on tourist trawling, the same fishermen, they are completely changed, because they see that this is not so hard job, that they are dealing with some 30 people, so they have to change themselves, and it becomes easier for them to pass winter months. Of course, with all the advantages, there are disadvantages also. First of all, I'm referring to the potential loss of the permanent buyer, permanent client. In winter, when we have the biggest income related to the other months, we have clients who are buying our fish, and they are not so happy because they reach the highest prices in summer. So when I say to them, I'm going to tourist trawling, this means there is no fish for them. So I have to balance this in order to satisfy these clients and buyers, because I don't want to lose them, because otherwise I will lose them, and then this will be a problem for me. A weak promotion. Guests tell me, when they come to me, they think one thinks that he goes to big game fishing, the other for fish picnic. So they do not realize that they are really going to tourist trawling until they try it, until they spend this day, one day. They still make this comparison of tourist trawling with some almost fishing, or fish picnic is definitely not fishing at all. This is something which can be okay, but doesn't go with this. Big game fishing is then completely different, a kind of elite fishing. This is something that can be close to great number of people. And of course, you are dependent on weather conditions. This is a problem, the biggest problem, because you prepare everything, you do everything, and then you depend on weather conditions, which simply do not allow you. Some days, for example, when we have big waves or whatever, because guests, they do not have this tolerance a level like classical fishermen, so you should have ideal weather conditions in order to do this tourist trawling. In contacts with the ministry, with science, we are trying to find some alternative solutions, so that the areas that in winter are open and allowed for fishing, that some micro locations could be open also for tourist trawling. so to animate the bigger number of fishing boats possible, because the more boats are activated, the less they are engaged in fishing effort. So 50% of a fishing fleet could start doing something like I'm doing, and with the existing measures of diversification, like temporary reduction, fishing tourism is an ideal example how we can reduce fishing effort and work on increase of the biomass of resources. This last picture that I put here, this is the picture of my boat 2 years ago, prepared with benches, with everything, waiting for the guests. But due to the actual situation with pandemic, I'm not quite sure they will come, but I did it so that my fishermen think that guests will come and then they will overcome this season. Thank you for your attention. Thank you, Mr. Perišić. This was very interesting presentation and the data he showed us. Do you have any questions eventually? So we completed this first part. We haven't foreseen any discussion as this first basic part is concerned. No questions? So I propose you to have a coffee break now and then continue according to our agenda to continue at 1:30 with Mr. Aleksandar Joksimović, Institute of Marine Biology from Montenegro. And I'd like to thank you all, to all of you who are following us on Zoom and on social media. See you at 1:30. Thank you.
Evo ga, zahvaljujem svima koji su se ponovno priključili, svima onaj koji su danas sa nama u hotelu Kolovare u Zadru na midterm konferenciji zajedničkoj koja se održava u okviru projekata, zajedničkih projekta InnovaMare i projekta SUSHI Drop. Današnja tema općenito je bila isključivo vezano na teme na projekt SUSHI Dropa, to je održivo ribarstvo uz prikupljanje podataka dronovima. Kao jedna od najvećih važnosti to su pouzdane i ažurirane informacije o stanju morskih resursa koje su ključne za donošenje odluka menadžmenta. Do te mjere kroz ovaj projekt se potiče korištenje podvodnih mobilnih uređaja opremljenih senzorima koji mogu pratiti osjetljivost jadranskih vrsta i staništa na ribolovni pritisak. Kao ključni poruke ovog projekta SUSHI Drop to su zaštita biološke raznolikosti, monitoring dronovima i dostupnost podataka. I evo ga, u drugom dijelu dana dio prezentacija koje su dosta stručnije i tiču se dijela održivog ribarstva na području Republike Hrvatske, isto tako i naše susjedne Crne Gore. Pa evo, prvog govornika kojeg najavljujem, to je gospodin Aleksandar Joksimović, koji nam dolazi iz Kotora i koji je direktor Instituta za morsku biologiju u Crnoj Gori. Gospodin Joksimović, molim vas da se priključite.
Hvala vam, dragi prijatelji. Izuzetno mi je čast i zadovoljstvo da danas evo i na ovaj način mogu biti sa vama. Nadam se da ćemo uskoro biti u prilici da se uživo gledamo, da se grlimo, ljubimo. To je ono što nam treba definitivno, jer naše malenkosti su socijalna bića i mi ne možemo bez druženja definitivno, ali poštujemo naravno mjere i sve ovo što smo trebali da do sada uradimo da bi zaštitili sebe i druge. Naravno, u ime Instituta za biologiju mora Univerziteta Crne Gore ja vas pozdravljam i naravno pozivam da ste uvijek dobrodošli u Bokokotorski zaliv, u Crnu Goru. Ovim putem želim da pozdravim moje drage prijatelje i kolege iz Instituta za okeanografiju i ribarstvo iz Splita, na čelu sa ravnateljem Vrgočem, dragim Jakovom i ostalim mlađim kolegama. Mnogo smo radili zajedno i radit ćemo naravno kroz razne međunarodne projekte, jer nam se čini da naše Jadransko more, kao jedan izuzetan biser koji imamo ovdje ispred naših obala, zaista vrijedi pažnju i istraživanje i naše naučne preporuke, a sve u cilju zaštite i njegovog što boljeg korišćenja i naravno ostavljanja čega i za naše potomke koji će doći
also for all our
ili nas kuditi ili nas hvaliti, pa vidjet ćemo, vrijeme će pokazati svoje. Naravno, naša saradnja kroz Adriamet projekat je značajna, to je jedna zaista dobra platforma.
A good platform here until with Montenegro has entered this story, and all the groups and all the people that we know have contributed greatly into the Adriatic Sea, so we can exchange our data and we can together go towards the European Commission and through our ministry and also through the General Commission for Fisheries on the Adriatic Sea. And I also would like to thank everyone, the team, the managerial team, who this year is especially working. For now, to just go back to my presentation theme, in our institute, about 10 years ago, the idea was born, the Center for the Protection of the Biodiversity of the Southern Adriatic Sea, and considered that this is a very important part because of the sea current that go through along the coast of Albania and then Croatia. Everything that enters the Adriatic must pass our coast. I would like to thank the person who started this idea in our bio center for the protection, and also what happened in 2017 is the application which was also granted by the Norwegian Ministry of Foreign Affairs to implement the project of Marine Diversity and Conservation Center of Boca Aquarium. And this aquarium is also a part of this story. We because of the bad assessment of everything that we need in these phases, some other institutes also were included, especially the Ministry of Agriculture and Forestry, and also the funds of the World Bank in Montenegro. And so we equipped this aquarium completely, and also we have the agricultural strengthening project allocated additional funds for the procurement of aquarium equipment. All this can be found in this beautiful building on the coast, which is close to Kotor, and about 300 square meters of space. And this we have established our first center of establishing the bioconservation. The concept of our story is nothing new, but something that already exists in the world. But the wish in this aquarium and this center to ensure the visitors in some 19 parks to see the importance of the types that are characteristic for the Mediterranean Sea, for our Adriatic, our deep littoral, and the flora and fauna, with specific focus on the Bay of Kotor, with a specific ecosystem with its specificity, and all these underworld sea and everything that people can see here. One is a center for the rehabilitation of sea turquoise, and it is in its last phase. This is what our aquarium looks like. It has 3 separate rooms, and it is right next to the sea, and we would like to show our visitors what type of species we have, and slowly in entering the B part, which is the Mediterranean, with 7-8 parks, and there they can see the species that are inhabited there, and we would like to see the richness of the diversity of the Mediterranean. And the last one is a touch pool, which is Bocco Kotor Bay, so we can, children here can see the types and have contact with these types, and also with a terrarium, which is a part of it all, where we can, which will somehow show our salt water and sweet water and everything that can be found around Kotor. This is actually everything that we wish, a list of wishes, and our activities here is that all the children in Crna Gora, regardless of their age, can come and visit us. And children who do not live on the sea coast, we can show them some species. We can show them crabs, squids, and so they can know what they look like. So they don't see them only in books, because Montenegro is a sea country. We have interactive workshops within the aquarium itself, and also some yards where we have some billboards with pictures, and every 15 days we will organize some type of manifestation promoting lectures and talking about sea vertebrates, so that in some of the yards we have an amphitheater with about 50 seats where we wish to show all our students and pupils to slowly have the experience of seeing what they could not see until now. So I can thank the aquariums around us, especially the one in Dubrovnik and in Pula. Those are the two aquariums and two institutes. And two of our colleagues are in a small training in Pula, and whatever they will learn there, we will use down here to be able to show our aquarium as best as we can. And this is what an aquarium room looks like. This is an aquarium of the 21st century with special effects, and with you can see the sea bottom. This is the bottom of the aquarium, which we treat as a sea bottom, and with lights and billboards where we can show that we are a very modern house, and we are under the protection of the UNESCO, and we are a monument of culture and nature, and we have the honor of showing this outside and inside. We have some educational offers, because it also has its programs. The concept, design, and established mission, the Center of the Adriatic Biodiversity, has special services. So here we have these we have them in various languages, and for our colleagues of the Institute, where there's a big potential of applying to the European funds and also withdrawing from the funds of the European Union. So we have this possibility for scientific projects. Of course, what was the problem last year and this year is that we could not open the aquarium on time, and we thought it had to be by the 20th of May, but now we got permission from the management board. We got some positive signals and financial assistance, and we hope that with the help of God we will open it by the 1st of June, and then we will have visitors coming, and we are very impatient, and we can hardly wait for this to be realized. It will be the first aquarium in Montenegro, and it will be a very good point for us in Montenegro when we have stopped with all our trips, as everyone has. And we hope that better times will come and all these problems will be solved and we can again cooperate and connect all these bridges that I hope will last for a long time. I would also like to thank at the same time to the Norwegian government with their help and assistance, the Royal Norwegian Embassy in Belgrade, and also Nicolette Mione, and our dear friend who was the coordinator of the project, Fabio Massi at that time. And the idea, which was after 10 years, has become reality. What I would also like to emphasize is that the Kotor Bay is open, and we hope the tourists will visit us and see these beauties. And what you see on your right is this is our institute on the small peninsula, and we really hope that we will be a light for Montenegro and hope that with our contribution we will help in the development of Montenegro, showing everything that we have, and of course with the regional cooperation, which is a key factor in every future story. Of course, I will just emphasize that now it is an active exchange project where we also, the partners are Bosnia and Herzegovina and Croatia, besides our institute and also the Aquarium of Dubrovnik, the nature park Kutel Blato, and the tourist organization of Mostar. And through this connected blue chart, all the visitors who come into our aquarium can also, with that same ticket, visit all the other parks and get to know all the parts of our dear countries. And if someone comes to Dubrovnik, that blue pass will also be valid to visit us, because we would like to raise our tourist potential, and not only for our citizens, but also for those foreigners who are coming to our country. And that much I would like to invite you to be guests here, and I hope that we will be able to see you in the future, and be careful with your health in the future. Bye-bye.
Thank you.
Thank you very much. A very interesting presentation. And with the help of tourism, we got to know we got our guests to know, and the domestic guests also, how to protect the sea that is practically our heritage, whether we live there or we just visit it as tourists. If there are some questions, we can go with the questions at the end of the session. And I would now invite Mr.
Mosor Paravan and Daniel Kansky from the company WWF Adria, Marine Program Managers. Good afternoon. It will be only me. Colleague Kansky is in public. It's by mistake that we both were mentioned, and at the end, this is my topic, so to say, and not his. When I started preparing presentation last night, I didn't know whether to make it in English or in Croatian. I prepared it in English, and I will talk in Croatian, and I've been told it doesn't matter, so I hope nobody would mind. The topic is protected areas in the Mediterranean, examples of good practice. Generally, the topic was given. Sounds straightforward, very simple, but actually this is not the case, because theoretically it is so, but it is not so in practice. You will see why and what it is about. Okay. What is a marine protected area? First of all, a definition, just to give a framework definition. According to International Union for Conservation of Nature, generally protected area, not only marine, is clearly geographically defined, dedicated through long-term protection of nature and resources that are located there. Why marine protected areas? Because they are established for the purpose of protection of nature, but they have the whole series of benefits, call it like that. Why they are established? This is first of all protection of ecosystem. Mostly it is a fishing system, fishing fund, but also we are talking about the protection from natural disasters, hazards, erosions, improvement of management, education related to protection of sea, and so on. In an ideal scenario, in an ideal case, when we have a protected area, efficiently protected area, which is very important because most of protected areas are not efficient. I'm not quite sure whether this is functioning. Yeah, it goes. Why do we have marine protected areas? Just one short reflection to that. These are the trends in Mediterranean regarding various trends that use marine resources or which operation is going on the sea. As you can see, for almost all of these sectors, we have until 2030 and foreseen increase. So we predict more than 100% marine traffic annually, more than 4%. Researches of oil and gas are considered to be increased for 5% at Mediterranean in the next 10 years. Cruising increased for 18%. The whole series of sectors. The only sector for which an eventual decrease is predicted is professional fishing. All these sectors have a certain impact on a marine area from emission of various emissions, impact on loss of biodiversity, impact on habitats, creation of waste, and so on. This is an interesting graphic. I wanted to put in context a kind of balance around which we are balancing, so to say. Just an estimated value of the economy of the Mediterranean is 5.6 trillions of dollars. So the so-called gross marine product. It's like the states have GDPs looking at the Mediterranean. They have this kind of product. And what we do have in this moment, we have this value in the middle, and we have those sectors that we mentioned previously that are using these resources. And on the other hand, we would have these marine protected areas or fishing protected areas, so-called FRAS, that are balancing about this exploitation, and we should equalize the whole story related to preservation of resources. Then when we look at the global, when we have a global overview, in 2017 we had only 6% of the cover of the sea surface covered with protected areas, because we wanted to be at 10% in 2020. We are now at 8% in 2021, and the big initiative called 30 by 30 predicts until 2030 that 30% of sea should be efficiently protected. When we look at the Mediterranean, we will see what I mentioned at the beginning, that talking about positive examples of protected area is theoretically easy, but not in practice. Generally speaking, or looking, Mediterranean looks pretty good. 9%, 68% of 90% of the Mediterranean is covered with some kind of protection. Here we have no fishing areas like Yabuka Kotlina. We are just talking about marine protected areas from the aspect of protection of nature. But what should be done in order to guarantee that marine protected areas fulfill their purpose, at least at a minimum level? This is something that you can see at slide. There should be a management plan, so that this management plan should be actively used, implemented. And the third thing is to do the monitoring of the plan, those items which are managed, so to see whether you are doing certain improvement or not. And according to that, you are doing the so-called adapted management. Now, to come back to the coverage of Mediterranean with protected areas, we come to this. So only 2.48% of the Mediterranean is covered with protected marine areas that have management plan. But when we look at those who have management plan, how much of that is implemented, then we go down to 1.27%, and included monitoring whether some area fulfills all these criteria, then we go back to 0.03%. So if you take into consideration everything that we mentioned previously, so we have areas, sectors, economic sectors of blue economy, which are increasing with the prediction of a significant increase until 2030. And on the other hand, we have such a situation regarding protection. Theoretically, if I would inherit such title from the example to describe the good practice examples, management of marine protected areas in Mediterranean, I would be talking about practically about 0.03%, which actually doesn't have much sense. But what could have sense to share with you is that a few years ago, 6 years ago precisely, a group of us in our institute, we asked ourselves, but let's see in this 0.03%, what is what they are doing well and the others are not? What makes this difference? Why some are successful, few of them? So to have this efficiency of protection, if we talk about fishing fund and habitats, when you are following the situation, then you should have the better criteria, better figures. Now, what they are doing that they have this effect and the rest of us, we don't? And those parks that do not have this effect, we just call them paper parks. And then we did a long-term study which showed the following, that those who have obtained good results, they implemented these 5 steps. First of all, they have management plan, but they pay attention to the implementation of that management plan enforcement, to have monitoring, to have control, to have people in the field who are taking care about to prevent illegal activities in the area. What we also noticed is that, first of all, fishermen and the other stakeholders are included in their management board, and also that they regularly do monitoring and follow the situation and research on the situation on the field. But they also, in this monitoring, include fishermen, and with that they increase understanding from their side why some operations are allowed and the others are not. And also fishermen are very often very good source of information because they understand very well ecology of a certain area. Also, they are helping these fishermen who are operating on this area to upgrade the value of their fishing, of their catch, to get certain certificate confirming the origin of some fish, not only about fish of good, excellent quality, but something that is even more demanded, especially on West markets, that the fish is from the sustainable fishing. And then, after we did this study, we asked ourselves, we said, okay, what can we do based on this data in order to help other parks so that they can follow certain guidelines and achieve these results? So we did a kind of handbook for management where you have all the guidelines for enforcement. You need to do this, installment of cameras, other forms of surveillance, inclusion of fishermen in management of park, then including of fishermen in control. But at the end, everything is very often just it's just a goodwill of those who are managing these areas, and unfortunately, there isn't any easy solution. It is always a question of time, of several years, not only here but also in other countries, which we sometimes consider maybe more advanced than we are. But very often it is the politics that plays a certain role, and when politics plays a certain role, then you have players playing from mandate to mandate, and these mandates are very often shorter than the time you need to make these important changes. So this is also an important obstacle for us to get better figures than that 0.03%. So now it is at the agenda of the European Union. You probably heard for Green Agenda that is going to be through implementation of the whole series of economic measures in European Union, with the target to have 30% of the European Sea under certain kind of protection until 2030. These are the predictions. As for Croatia, we are at the moment at some 2% protected marine areas, but we have also the network of the protected areas, and we participate with 16% in this European network of protected areas. I have to say that it is more theoretically, it's not like that in practice, and that would present an important challenge for Croatia in the coming 6 or 7 years to do some very important and significant changes, not only for Croatia but for other EU countries. How it looks like when you have one protected marine area with the zones without fishing, but also zones of complete protection, and what can be seen there, what can be achieved in such areas. It is achieved that we come to the phase that of kind of virgin sea, so meaning that you can see in these areas things and objects that you couldn't even dream of. This was confirmed in Jabučna Kotlina. We come to unexpectedly fast rehabilitation of fish. This is important. Oh, yeah, that's the video. Which is important not only for the protection of nature, but also for fishermen, because then that fish is spreading in surrounding areas, and fishing becomes better for fishermen. I leave you now with my video, and thank you for your attention. Images like this one, because this was not recorded in the Adriatic Sea, unfortunately. Let's support the establishment of the zones without fishing in Croatia. This was recorded in France, in a park in France.
Pogađaš li koja od ovih namirnica ubija muškost?
Which?
Okay, this is a very inspirational introduction for our next speaker with Dr. Isalovic from the Laboratories, the Institute, Laboratory of Fishery Science and Management of Pelagic and Demersal Resources. I would like to greet all the participants and those who are online. And I will speak about the protection of biodiversity, especially in the Yabuka Kotlina Pomo pit, the Yabuka Basin. And when I'm talking about the fishing biology, we know that biodiversity for us is the richness of the sea and the when we speak about all the various cultures of this richness of the sea, we can say that in the world and in the oceans and the lakes and the rivers, there are more than 30,000 fishes, more than 12,000 crabs, and 800 types of various other fishes. The energy we get from this sea is about 700 types of fish and 300 types of crabs. And we look at our Adriatic Sea, which is which is a part of the Adriatic Sea. We have 240 crabs and 35 types of fish, and about 150 of them are where we have an economic interest of being economically important. So we just look at the Adriatic Sea and its specific place. It is a small sea, and because its surface is 140,000 square kilometers, and it is the part that covers the zone that we say are GSA 17, which is the Croatian territorial sea and the open sea, and up to the Italian coast, because it is quite diverse in its hydrological aspect and its geomorphological aspect. There are very big differences between the north and the south, and also between the west and the east, where we have completely different structures and sea bottom, and also hydrographic characteristics. In that area, we have two important: the deep part of the Adriatic, because the Adriatic is quite a shallow sea. It's about 200 meters, because in the oceans, we have about 3,000 meters of depth, while the Adriatic is only about 200. We have some places which are deeper. The South Adriatic Basin, which is the Yabuka Kotlina Pomo pit, which got its name after the island of Yabuka. The characteristic of this area is that the factors are quite stable, and it has no here organic things are very slightly created. If you look at the hydrological characteristic, as Professor Joksimovic earlier said, the situation here is quite complex. The current here mainly go through the Otrant Strait, and they go from the east, and where warm Mediterranean sea comes in with a lot of salt, and it goes up to the north part of the Adriatic. As you know, the north part is very shallow, where the depth is about 30 meters of depth. That is an area where there is a photosynthesis, because the light goes way down to the bottom. And since it's very shallow, that part of the sea is much warmer than the rest of the Adriatic. And also what is interesting is because of the karst rivers, the Istrian and Slovenian ones, a lot of organic substances come here. So here we have photosynthesis, a lot of organic substances, and here we have a primary production here, because this is a very nutritive part. When the winter comes and the temperatures go down, that warm sea becomes colder, and with the cold currents, those substances spread and they go up to the Yabuka Basin, and that's where they retain themselves. And here we have some stable conditions, because the temperatures throughout the year there are stable, they don't change, and a lot of quantity of organic substances, and it enables us to have an ideal state for the development of various samples of very important economical species, because this area is very important due to this aspect. Since we know that this is a very important, so we have done a lot of research on the Adriatic Sea, and we have found the biodiversity here, and to see what we find, the stockage on the Adriatic. First, what is most important research was done in 1948 concerning an expedition, Quadia. So we found the virgin state of the sea. In 1948, there was no fishing. Due to the Second World War, fishing did not exist, and after that, when expedition was performed, we saw the sea bottom of the untouched sea bottom. And through the years, we did a lot of researches, which were performed later in cooperation with our scientists and Italian scientists, and in the 70s, 80s, and 90s until today, many researches have been performed in the Adriatic Sea. So now we have a general picture of the state as it was once, and all the changes that through anthropological activities, and now we can say that how all the changes happened throughout these periods. And if we see all that, look at all that data, we have established that the Yabuka Basin is a critical part for the development and growth of the most important parts of the Adriatic Sea, as hake, as Scampi, and various other types of fish. And if this is very important, then the Adriatic Sea is very rich with live richness, and the fishing here is great intensity. If we look at the fleet, we can see that the Republic of Italy and Croatia have more than 6,000 vessels that perform fishing. Of that number, we have about 900 vessels that use some special devices that change the sea bottom, and they have a very big effect on the biodiversity of the sea bottom. And all this equipment is very destructive for the sea bottom. And according to GPS data that we had concerning some vessels like trawlers, we see that the Adriatic Sea in June of 2015 was actually plowed. We can see all this part is with the Yabuka Basin, with the greatest intensity of fishing. And according to our scientific data, we started negotiations with, in order to protect the Yabuka Basin, and the Republic of Croatia and Italy, with bilateral agreement, agreed that this area would be protected further. And after that, using all our scientific data, we can say how all these changes have come about throughout these years. And as we said, this area, especially the central part, was first protected by stopping fishing there in international waters of Yabuka Kotlina in 2015. Then the protection of this area, which was critically very important, was not protected, actually, and we used the devices that were prescribed by the law. And in these periods of prohibition, these periods were very, very short-lived. And after these negotiations, the first zone of protection was established, which lasted for only 1 year. And after that, we just protected one part, a very small part. And during this year, we saw through scientific research that we had a very positive step ahead, which was biological protection. In order to protect this part, with negotiations of NGOs and our country and the Italian state, then we had a permanent prohibition of fishing in Yabuka Basin on the Adriatic Sea, and then other 2 additional zones were added, A, B, and C, where fishing can be performed, but very restrictively. And in the end, then we have this area, which is more than 3,000 square meters, which is a no-take zone. It has 1,500 square kilometers where fishing is completely prohibited, and this is under a great regime of management measures. And this type of prohibition has become the sea aeroplan of the Adriatic Sea. So just to see how this took place, according to researches that took place with expeditions, Expedition MEDIS, that is the main scientific expedition of demersal species, habitats on the Mediterranean, and it was performed in all the Mediterranean countries using the unified method and devices and equipment. So here we had the chance with joint researches to get a picture of the state, and we can compare the data on all the Mediterranean. Now, when we can see on this graph, we see that in the years 2000, what the mass was in those years for the industrial zone, and the red line shows us the stock that we had in the no-take zone. So we can see in this very small, during this short period, in the small area, the rehabilitation recovery was quite good for important species. The entire basin, which is shown here with these columns on the second one, the no-take zone is shown here, even during 2015 in 1 year, with the prohibition that lasted, then we saw the recovery that took place. And now the recovery is quite obvious. So we can see it here, how the state with the fish population, especially the state concerning the sharks. And we can see that sharks, for us, are a type, they're biological indicators, since they are a type that live for a long time, grow very slowly, don't have a reproductive power, and they are very sensitive on any type of fishing activity. And that's on the other side, biologically, they are predators, and they're very important for keeping the biodiversity on the sea area. So we can see that the situation, especially in the no-take zone, is quite significant, and it recovered quite well, so that the effect of this mechanism of prohibition was quite effective. We see also the situation concerning crabs, and we saw that they were recovered significantly. And also all these areas in the basin, you can see the blue columns and the other ones show us the further area of the Yabuka Basin, where you can see how the recovery took place throughout the years. So we can see the Yabuka Basin is a very important for hake, which is the most important type for fishing for our economy. And also it shows how it migrates, how it grows in the Yabuka Basin and migrates through the rest of the Adriatic Sea. And it is also a basin for this. We can also see for the other important species, and especially for Scampi. Scampi is among the most important crabs of the Adriatic Sea. We can see that its biomass in the past years has been in a negative phase, in a negative trend, and they were almost completely devastated, its population. In this protected area, a very significant recovery took place in the wider part of the Yabuka Basin and the Adriatic Sea. And with these results, influenced by these results, we made further research, and this further data comes from the expedition MEDIS. And to be able to get a complete picture, we use the same methodology during the winter research done during the winter season, so we compare with the summer variability in this area. You can see the red part is the no-take zone, and the other ones that we see are the buffer zones, where the fishing is allowed but very restrictive. And we see the international waters here, according to the Croatian ZEF. And when we compare the state after 2 years of prohibition in various parts of the Yabuka Basin, we can see that in the no-take zone, we had a very significant recovery. Not only in that this recovery took place in the no-take zone, but also in the surrounding areas, because these protected species that live here migrate in the surrounding areas. So we can see what the state is like in the other parts of the Yabuka Basin, where we see that a lot of recovery took place. And in this part here, which is under the Croatian jurisdiction, Zone C, and we can also see in the other economically important species. We see that a significant recovery took place on the biomass of the fish, especially for sharks, and also for crabs and scampi, because this Yabuka Basin is most important for the distribution and development of scampi on the Adriatic. And now we talked about biodiversity, and according to scientific research. So now we took data that have been gathered through a PCF program, where we describe the state of some general trawler on the Croatian part of the Adriatic. It's a trawler that performs fishing mainly in the part of the Yabuka Basin, because in the earlier years, this was a usual number of days of fishing, and the fishing was performed in the cold part of the year, while in the warmer part of the year, due to the prohibition of fishing and protection of various species, the intensity was feeble in this part of the year. So when we look at how the catch took place, and due to the prohibition, we saw that there was a big rise of fishing in the mid-central Adriatic in 2015 and 2016, and intensive growth. In 2020, there was a fall in the catch, but if we look at the picture, that is a consequence of the COVID, because due to the COVID situation, some of the fishing was stopped in some areas, but we also see that the total catch did not significantly fall according to the number of working days. And we also see, considering the situation of the main business type, we see that there has been an increase in the catch and the productivity and the profit of the average fisherman and his entire fishing year. So with a small percentage of protection, we have realized 1.5% on the North Adriatic, which have shown very positive effects on the biodiversity and also on the management and business of fishing. Thank you. This is a short presentation of the state.
I don't know if we have any questions. No questions. Thank you, Igor, for this interesting presentation, which gave also the survey of what's going on with the main species. But also, besides that, there are some invasive species in the Adriatic. And who can tell us more and better about this than Professor Dulcic from the Institute to present us these new species that are appearing in Adriatic Sea? Professor, the floor is yours. I will stand like this, can I? So, greetings to everyone. I hope this presentation will be, let's say, more interesting, so that it will wake you up. It's becoming a little bit hot. The title, Exotic Fish and Decapods in the Adriatic, Grade 4. Are there any reasons for concern? This Grade 4, some older of you, I can't see anyone who's older than me, can think about the former Grade 4 football teams. But I applied this Grade 4, but this Grade 4 can be always changed due to the number of species and also due to their presence in certain areas, and in this case we will be talking about our Adriatic. But just a short, we will have to tell a few words, because here we are talking about autochthonous. Just to pass these terms, autochthon or native species is a native species, is that species that naturally lives in certain ecosystem of certain area. This is generally definition. Foreign species or allochthonous, not native, not original, exotic, introduced, broad species, which is now a term which is very often used, because I'm preparing for the Atlas in Monaco. This exotic is more attractive, especially for those who are not directly dealing with these topics. But exotic sounds a little bit stronger. Introduced, meaning if some species are introduced on purpose from some reason, like Amblusia hongboki, which was introduced in order to destroy mosquitoes and malaria. Then invasive foreign species, alien species, which is exotic, non-native, not original introduced species, which was introduced with the help of man in certain ecosystem, and in which this species is not naturally present. invasive alien species is the species from which it was established that its introduction or dissemination dangers or has a dangerous impact on the biodiversity and all the connected services of ecosystem. Generally, the whole Mediterranean as a hotspot of biodiversity is today, or faces today, substantial changes, which is reflected to flora and fauna, but also as our Adriatic is a part of Mediterranean, so is our Adriatic exposed to all these pressures. And during last few decades, we can say that also our Adriatic was exposed to many changes, like due to climate changes, to activity of a man, human activity, and a process which we called Lessepian migrations, which is a process that is going on from the species that are in Red Sea to Suez Channel, and they come to the east part of Mediterranean, and then they spread to the rest of Mediterranean. For many years, Messina Passage, or that threshold from east to west, was a kind of problem for those species, but for some of them it's no longer a problem, and they just intrude, they just go into all parts of Mediterranean. As for majority of the fish species that are recorded in the Adriatic Sea are Lessepian migrants of Indo-Pacific origin. Out of 15 so far recorded Lessepian fishes, 3 of them are somehow, we can say, they already established their population. Some of them for the zone of the whole area, those 3, I will show you later on which, and some of them only partly, only on some parts, mostly South Adriatic. But one is also in front of us, that is Pteris miles, which shows recently a rapid expansion in the Mediterranean Sea within Levant. But you will see that it is almost at the entrance in the Adriatic Sea. We do hope that this species will not come to Adriatic, because that would mean heavy consequences if such a species enters Adriatic Sea. So just a short survey. So fish are known to invade the Mediterranean through 3 pathways. One of them is Gibraltar, or Hercules Pillars, which is used very often in certain countries, or just Gibraltar. A second is the one I already mentioned, Suez Canal, Suez Channel. No more 1, 2, we have now 2, a little bit expanded so that these species can even more invade from Red Sea. And the other term, which is used for Lessepian migration or Erythraean migration, but I advocate this philosophy that these are Lessepian migrators, because as I said, I'm working for this institute in Monaco, and you will see later on, we are now in the phase to complete. This atlas should be published this year, the Atlas of Exotic Fishes, which is actually done by the International Committee for Research of Mediterranean. And the third way is by human activity, be it by ship, mostly it's not so much balanced waters, but with the space where the so-called sea chest is located. More species come to sea chest than they come with in another way, by ships. They escape from some marine cultures and so on. We don't have time for more details. As you can see, some books are published on the topic Fish Invasions of the Mediterranean Sea, Change Renewal. So this atlas that I mentioned, I have to press white. CM's Atlas of Mediterranean. This one is related to crabs. And the new one, the new headline, it's a new edition for fish, such as invasion of these new species, who mostly, I say mostly, Lepsepsian migrants, that there was a need to publish a second edition, a second part of this atlas. So I hope that this will be finally published this year. As you can see, this is over 100 Lepsepsian, around 100 Lepsepsian species of fish that will be included in this atlas, not counting the others who arrived with other vectors, other pathways that I previously mentioned. If we look at the geographical origin of the species that are now recorded in the Adriatic Sea, as you can see, more than 60–65% are Atlanto-Mediterranean species. But what is important, this last topic, almost 5–6% are those species which do not originate, they originating outside the Mediterranean area. So this increases drastically, this number increases drastically, and within these 5–6%, we have almost 50% with the origin from Pacific. So these are these grade 4 that I mentioned before. So first one, Lagocephalus sceleratus, or silver 4-threaded. Second would be Siganus luridus. I have to press this one to show you this Fistularia commersoni. And on the 4th place, I changed this because this is the drastical innovation, because we have more and more in order to almost exploit it commercially, and this is Calinectes sapphilus. But with these 4, along with these 4, we should add those that I already mentioned, these Pterois miles, lionfish. Although I found a Croatian term in some books from the beginning of the 20th century, like a Croatian term, vatrenjača, for lionfish. So, yes, firefish. We have another example of at the moment an actual species. I would call it invasive autochthonous species, which numbers in the last 10 years extremely increased, and its expansion towards the north part of the Mediterranean is extremely high. It is that it causes many damages. This is one of the example of the invasive autochthonous species. A small cancer. We can say that Adriatic for a long time opposed to this species. We can't make any comparison with other similar species, because he is undoubtedly here. Mostly we find it mostly on the island of Vis, on Palagruja, and he is now this crab is at the 4th place within these 4. This is what we who are dealing with Adriatic, and something which concerns us a lot is because if by any chance they will be more present in Adriatic, the only prevention for dissemination of these species would be temperature in Adriatic for those species coming from Red Sea. Because you can see the example that for the fish that used to live only in south path of Adriatic, there is no problem now for the species to disseminate. My colleague Igor mentioned already biological indicator. I didn't put it here because I can't count it here, but it has always been a part of the ichthyophala of Adriatic. But then I had to mention this species that used to be found before in south part of Adriatic, but it is so numerous that it is fascinating. You can find it in the north part of Adriatic. But what is interesting with this baristes? Colleagues in England and in France use it as the biological indicator for increase of temperature in Gulf Stream. With the normal temperature of Gulf Stream, it can be found at the coast of Mauritania, Morocco, something like that. But when the temperature goes higher, he goes to the Irish Sea in great quantities. So it is used. So if you look now, where we used to find it before only in the south part of Adriatic. Now you can see it in the north part of Adriatic, in Trieste Bay. This is an indicator of the heating of the seawater in our Adriatic. So we don't need physics anymore, so you can see through these organisms that something is not correct. So these are the examples from Adriatic. I went mad when I saw this picture. If you can see, when they are offering you fish in restaurants, they do it like this. So I warned them that they should not consume this. So then an old man in the port of Bruges caught this species and he just brought this and just put it like this, and that picture went to the nearby restaurant. But I immediately said that this species should not be consumed. And these two children here in Tribune was so far the northern part where this species was found. But these two children were so smart and clever that they had gloves, and they put this fish like this in gloves, and their dad wanted to put it on a barbecue, on a grill. So, but there is a poison in the body of this fish, which is 1,250 ways stronger than cyanide. Apart from this, this is an ideal, delicious food in Japan, but with special preparation. But it can happen that it can cause death. But you know, Japanese are kamikazes, so they are kamikazes also in gastronomy. There is another species, which very often species are replaced and people confused, and people don't know which one is which. We have this one, Lagocephalus sceleratus. We have 3 findings of this species also found in Adriatic. So have a look all around Mediterranean warnings. Attention, dangerous fish, do not eat, and so on. So also we did similar warnings, leaflets, in which we wanted to inform the public, for fishermen first of all, to handle these species. Were there any death cases at the Mediterranean? Yes, Libya, Lebanon, Egypt, Israel, no. in the countries where the wider public was not informed about the danger of this species. And our project of local ecological knowledge and fishing research in Croatia changes in biological diversity of our Adriatic. So through our project, the most important sources of information for us are fishermen. Without fishermen, we would bankrupt if we would start directly researching these species. Of course, with greater abundance, we would gather easily these information. So we do have certain plans soon. This is especially linked to this crab. So this is this flyer that we distributed around, and warning about these species that shouldn't be consumed, but also, if caught, that they should be handled very carefully, because the sting of some species can also bring to death. So that dusk is pine food. As you can see that there is already through USCN, there are warnings regarding these species. This is the species that is very numerous in the south part of Adriatic. Some were found in the North Adriatic. For this can be easily said that already established its population has the impact on the herbinal species, on the species that feed with algae. So that we already know that in Levant, in the coast of Turkey, Israel, Cyprus, that it surpasses the original species, and also its sting can be very painful. So far, no death cases, but a painful sting. This is the proof of what I sell for Saganas. So juvenile fish species were found. You have this spawn, not yet capable for reproduction, but at the same time, this spawn represents the first sign of establishment of population. So there is something where spawning is already done. There are certain points and areas. We suspect that it is somewhere in the south of Adriatic, around Molund. Fistularia commersonil, blue spotted cornfish. You can see in one part, but you will see now in the next slide, they call it the Lesepsian sprinter, because it invaded the whole Mediterranean so fast that it's almost incredible. So you can see it from the entrance down at the Suez Channel, then the whole area of Mediterranean. You see the south part of Mediterranean, and can be more often found along the coast of Algiers towards Gibraltar. So this species is almost, we can say, within 10 years, has invaded the whole Mediterranean. It is fed with Barbatus, Pizzara, Affia minuta, all kinds of species. It is very aggressive, located so far only in south part of Mediterranean, of Adriatic, not so numerous, but you never know what will happen in future. This is very interesting example of the impact of information in Lebanon. They received from an old fisherman where they found this dried species. See how he's holding this. 25 years before its official record, scientific record of this species. So 25 years before, he had this species. So 25 years before, this species was caught. Such an information you can receive only from the talking to fishermen. Here we are at the blue crab. These are the photographs that we did in Neretva Voli, the Litva area, where is the habitat of the blue crab, though you can find it along the whole our coast. I think it established a small population at the west coast of Istria. You can see here repaired net, you can see how fish pot, you can see how fish was, so it destroys tools and consumes fish, other fish, so causes damage. But it's very tasteful and could be used in for economic purposes. So we could, if local fisherman community can catch it, fishing it, selling it, and they are already doing this in Montenegro, because there's lots of these species in Montenegro, and they are selling it immediately to the restaurants along Bojana River. Besides all these things, it feeds with the small fish, causes damage, but it was also recorded that it can transfer cholera. So this is something also why we should be very careful, because he can bring certain problems. This is just a small crab. I think I'm running out of time. Pterois maris, devil, farfish, lionfish. See how it looks? I was impressed when I came to Porridge and I see the commercial for aquarium, and on the image is this species. So commercial for aquaria was with this species, as if they have the feeling that it could soon come to Adriatic, because it is extremely attractive for aquarium. You can see here gradually the findings. Just one small note. On Cyprus, we have the conflict of MPR, marine protected areas, and the professional fishermen, because fishermen would use dynamite just to catch this lionfish, while the others would like to prevent that, because in marine protected areas you have divers, and they record this attractive fish, and then comes a ranger and makes him pay the fine. So this is this conflict between fishermen society, especially in Cyprus, and marine protected areas. But my concern is mostly here. I don't know if you can see. This is the latest findings. Kerf, the island of Kerf. I don't know if you know. This is a part of Adriatic Sea. The island of Corfu in Greece. So officially, Greece is Adriatic state, officially confirmed. But he did not pass this frontier. But the islands, North Islands from Corfu, they are inside the Adriatic Sea. So Greece has the right to say that it is Adriatic state. And see here the latest findings. He was found here at the Corfu. Again, it was the information came from the fisherman. And then on the other hand, you have South Sicily, where also some latest findings of this species were done. This one invaded Caribbean, so they had this kind of warning, please report all sightings, identify the location. And he caused disaster at Caribbeans. Almost 75% of biodiversity of venting habitats were destroyed. Besides that, besides the fact of being very dangerous, it has this poisonous part. From the sting, you can die. You can die from the sting, from these 7 thorns. From the sting of this fish, you can die. But as I say again, from my colleagues in Turkey, I received an appeal, warning, be aware, pay attention. And finally, I received a book of recipes for this fish. they simply cannot eliminate it from the ecosystem, and they leave the possibility for this fish to exploit it, and they left me a book with recipes. So in case this species enters your sea, I don't know if I gave you the video how rangers on Caribbean did. This species is simply fantastic. I wanted to mention this. I forgot to say that for the Mediterranean. What is the problem? There are no predators which can consume these new species that arrived. No more predators like this, no more sharks, no more organisms that are predators on this species. This shows you how the ecosystem of Mediterranean Sea is vulnerable, including our sea. That is how it was like. It is reproduced several times during the year. The only weakness is because it is very slow. They cover the whole cliff, and you can't see anything from them. They're very slow, but you can collect them very easy. So you have here the data that it consumes over 70 species of autochthon species, native species, and this moment we wouldn't like this species to come. Okay, for aquarium, but that's how it's escaped from private aquarium on Caribbean. This is Pomatomus saltatrix. Findings in the bay close to Porridge, so west coast of Istria. The first and the only way in the world, according to scientific literature, not anywhere under 14 degrees. And here, the temperature in January was 11.2 degrees. Not only one species, not one, but tons of this species in Istrian Bay. I don't know if I thought to show you a small video just to ask you if you are concerned like I am. So watch for invasive species. Here you can find some of them are already in the Adriatic, like this Fistularia, Pastefanolepis, just several kinds, Siganus luridus. They are here. Publications, information about these species you can find in these booklets from Tonko Šoljan's book, Fishes of Adriatic, which was first published in 1948, until the latest Adriatic Flora and Fauna. And the latest fauna of Adriatic Sea, there are already new changes, so we managed to put some of them in the introduction part. Changes occurred and the book was already published. This will be, I don't know how, because I keep on changing these numbers, these figures, because FAO are not working, they're working at home, so Handbook of New Fishes and Decapod Stations in Adriatic Sea is already finished, completed, but not yet published. And this is the latest Atlas of Exotic Species in the Mediterranean under patronage of the Principal of Monaco. I've been told that it should be published in June of this year. Film, can we see the video? Can we see the video? I think yes. This is a video. I'll tell you what it is about. This is one part. Second part. Colleagues from Turkey. When I was at the Congress in Bodrum in Turkey, we had so many people, so many participants, only about one And the only species, this was a smaller part, and now you will see pufferfish in Turkish marine waters. They have 8 kinds of this fish in their sea. 8 kinds of this species. In Turkish waters, only Mediterranean, no in Black Sea. I think you will just hear the voice. I think it's in English. This is Lagocephalus scleratus, and you'll see some others. Ah, yes, yes, we can see this.
Balon balığı. Ağı kesebiliyor mu? Ağı kesiyor. Deriyor ver büyük. Kesiyor da bütün vurduğu yer o hiç yaramaz artık. Anladım.
Je uništavanje plijena u mrežama, jel? Ali ne samo, evo pogledajte kako štete nanosi.
You see the damage they make.
Kaç çeşit gördünüz şu ana kadar? 4 çeşit gördük. 3-4 çeşit balon balığı gördünüz. Peki çok teşekkür ederim. Kolay gelsin. Rastgele.
Sad ćete vidjeti niz vrsta.
See now a series of species of this tetrandidid. This is ours, Lagocephalus. We call it our Lagocephalus. This one is already in Adriatic. This one is also, but I wouldn't include this one. This is Professor Turan, the one from the glasses. See how big they are.
Znači oni već imaju problem sa mladim, postavljene su populacije bez ikakvog problema.
Abi hocam bu balon balığı olanı biz ahtapot süpüye görmez olduk. Biliyor musun? Abi onlar çok büyük zarar var. Ne gibi yani ne diyor? Abi ahtapot süpüye bayılır işte o hayvan. Değil mi? Denizde çıkmaz oldu eski süpüyeler ahtapotlar çıkmaz oldu. Her şeyi yiyor. Her şeyi yiyor.
Eating everything. Ovo nije Scleratus.
This is not Scleratus. You will see now a dolphin, dead dolphin.
According to our project results, Lagocephalus spadiceus is not a toxic fish. Lagocephalus scleratus contain lower levels of toxin in spring and summer than the other season, which are spawning periods. They have lower toxin levels, especially in their muscles, in spring and summer season. However, Lagocephalus scleratus contain high level of toxin in winter and autumn season that cover non-reproductive period.
I hope this was interesting. Thank you.
Okay. Thanks to Professor Dulcic. Do you have maybe some questions? No questions? For the end, now we have Mr. Ivan Sekovsky with his presentation. Mr. Sekovsky comes from the institution in Split, and he will be UNEPMAP. We will hear him online. A good day to you. I will just enlarge my screen. Can you see? Yes, just on full screen.
I will give my presentation in English, if that's fine. Hello to everyone. Good afternoon. My name is Ivan Sekovsky, and I'm a program officer at the UNEP-MAP Priority Actions Program. I would like to greet all participants, and also I would like to thank SUSHI Drop for giving me opportunity to present. My presentation today will be on the importance of seagrass in climate change mitigation and adaptation. The seagrasses are one of the most valuable ecosystems on the planet. In Adriatic, we have 4 species of seagrasses: Posidonia oceanica, Cimodocea nodosa, Zostera marina, and Zostera nolti. I will focus more my presentation on Posidonia oceanica, since it is the most widespread of the seagrasses in the Mediterranean and probably the most well-known. It is very sensitive ecosystem that is endemic to the Mediterranean Sea, and it grows until 35 to 40 meters of depth, and on Mediterranean level, as we can see on this image, it covers around 25% of the sea floor that is until this depth. It is called the lungs of Mediterranean because it's very important in providing oxygen. It can provide 14 to 20 liters of oxygen per square meter per day. And it supports a wide variety of animal species. In Adriatic, it is assumed that around 1,000 animal species live in around the Posidonia meadows, either as a breeding area for them, either as nursery area, or they spend some part of their life cycle near the Posidonia meadows. And this, of course, is very important for fisheries as a source of food, and also livelihoods as income to fishermen and to coastal communities. Usually, Posidonia is mentioned in the context of hotspot of biodiversity, as it was mentioned before, but it has very important role in climate change adaptation. It is very efficient in carbon capture, which contributes to the carbon sequestration, and actually this is a strong contribution to mitigation of climate change. That's why it is known as blue carbon sink. And it is very efficient in doing so. It can capture carbon up to 35 times faster than rainforests. And although it covers around although seagrasses in general cover around 0.2% of global sea floor, they can absorb around 10% of ocean's carbon each year. So we can say that they are very efficient machines in capturing carbon. And here on this graph, we can see that after tidal salt marshes and mangroves, seagrasses are the hotspots of carbon sequestration, around, let's say, by average 80 grams of carbon per square meter per year. Also, another role important of seagrasses is the role in climate change adaptation. Basically, this is very important for sandy coastal areas because they grow on sand and they stabilize the sand. This means that actually they dissipated the wave energy by stabilizing the sand, and also they reduced the current velocity with their leaves. The result of this, some data suggests that maybe the waves passing over this elevated, let's say, area of Posidonia meadows can be 10 to 20% lower. That means that it reduces the flooding and erosion phenomena in coastal zones, which is quite important, especially in context of climate change, because this kind of impacts can be more severe with climate change, of course. While I was doing a bit more research, I also find out that, for example, in the Sakarum beach in Croatia, they established a connection between erosion of the Sakarum beach with the decline in Posidonia due to tourist activities, and within the project called POSEB Med 2, they engaged in a better protection of Posidonia in order to reduce the erosion phenomenon. So what are the main threats to seagrasses? First, this is pollution and eutrophication. Basically, they are indicator of water quality. They grow only in clean seas. Coastal artificialization, especially coastal hardening and beach extension, because this material can smother the seagrasses and also increase the turbidity, which then limits the sunlight reaching the seagrass. Also, improper fishing activities such as seine fishing and trolling, if it's not carried out in a proper way. And also, I would say that one of the most pressing threats, which causes the mechanical damage by anchors and chains, and also invasive species such as Caulerpa. And here on the right, there is an image of Acrotamnion preisi. This is a small algae that is apparently originates from Western Australia, and it's very distributed in Indian Ocean, and it has been observed in Adriatic or in Mediterranean for, let's say, 10-12 years. But last year it spread significantly, as it can be seen on this image. But you know, the effects of this spread are still being investigated. All these cumulative threats lead to impacts. Posidonia's decline in Mediterranean is around 10% in the last 100 years, around a third of which happened in the last 50 years. So what to do about it? First, there are protection measures, conservation efforts to protect Posidonia. And actually, it is being legislatively, let's say, well covered, because it's covered in Habitats Directive as a protected species. Also, it's monitored according to Water Framework Directive, Marine Strategy Framework Directive, and it's also protected in the list of species that are either endangered or protected in Bern and Barcelona Convention. Now, today, with the development of geographic information systems, a better monitoring and cartography and mapping of Posidonia can be, let's say, overlaid with some activities that can be harmful to Posidonia, and this can be very useful input information for marine spatial planning. Then establishment of marine protected areas. We had very nice presentation by Mosor today. I found some data from 2013 that only 4% of Mediterranean Posidonia is found within some of the marine protected areas. And of course, education and capacity building. You know, people who are involved in nautical tourism or fisheries need to know more about its importance. And better enforcement of these measures is needed. For example, limitation of certain fishing activities such as trolling exists. They cannot troll, you know, within certain distance or certain depth. Also prohibiting beach extension operations which are near Posidonia meadows. And plans for less intrusive anchoring, meaning to install floating buoys for mooring so that the anchors don't need necessarily to be put down to damage Posidonia ecosystems. Also, another way of preserving Posidonia is replanting. This is very site-specific. It needs to be ensured that the planted Posidonia is let's say matching to the environmental properties of the area where it is being planted. It can be very labor intensive and considerably financially. It can be considered a financial expenditure, especially in terms if volunteers, for example, are not available. Then you need to pay for the divers and so on. And also one limit is that it's very slow growing species, 1 centimeter per year. So it needs to take some time to see whether this kind of project was successful or not. Here is just 2 photos from the Interreg SASPAS project, where there was 2 years ago or previous year, I cannot remember, there was planting of Posidonia shoots in National Park of Kornati in Croatia. So why am I talking about seagrass today? My institution, PAPRAC, is one of the partners in AdriAdapt projects, which has the main aim of the project is to develop the platform, which will be aimed to Adriatic stakeholders in Croatia, in Italy, actually to local authorities who wants to develop some kind of adaptation activities to climate change. And among 40 to 50 adaptation options, we decided also to focus on blue options, which is not frequently the case. So apart from the option of conserving and rehabilitating the seagrasses as an adaptation measure, we also describe the measures such as establishment of marine protected areas, diversification of fisheries and aquaculture, and risk-based zoning and siting for aquaculture. This platform is under development, but hopefully it will be finished, it will be ready until 30th of June when the project ends. So we will be more happy that we have people visiting it. Basically, that's it from my side. I have a concluding remark that is very simple, that is with stronger effects in seagrass conservation and restoration. We will better mitigate climate change through carbon capture. We will better adapt to climate change by reducing the flooding and erosion phenomena. And we will better protect university, have continuous provision of food, income, and marine eco-services. Thank you very much for your attention.
Hvala Ivanu. Evo, približili smo se samom kraju.
So we have reached to the very end of our working day, second day of our conference. I hope that all of you that were with us, personally with us in Hotel Kolovare, and all of you who followed us through Zoom and social media, that you are satisfied, content, that we presented you the actual situation and what is working on the territorial Republic of Croatia within InnovaMare SUSHI drop project. Here we will definitely have some open questions to which we should keep on working, not each separately, but including all the stakeholders from various spheres, from various fields, respecting everyone's opinion. Once again, thank you all for your presence, and finally I would like to thank to our technicians, our interpreters who were excellent. Thank you these 2 days, and to hotel staff who hosted us very well. An applause for them at the end. Thank you. Thank you.